This is a question from engineering mathematics. Which of the following is true? Root 3 plus root 7 equal to root 10. Root 3 plus root 7 is less than or equal to root 10. Root 3 plus root 7 is less than root 10. And root 3 plus root 7 is greater than root 10. So let's find the solution. So we can write, first of all, let's square the both sides. That is root 3 plus root 7 the whole square, as well as let's write root 10 the whole square. This is of the form a plus b the whole square. So we can write it as root 3 the whole square plus 2 into root 3 into root 7 plus root 7 the whole square. This is equal to 3 plus 2 root 21 plus 7, which is equal to 10 plus 2 root 21. And now root 10 the whole square is equal to 10. Now we have this is root 3 plus root 7 the whole square is equal to 10 plus some positive value, whereas root 10 the whole square is just 10. So from this we can say that root 3 plus root 7 is definitely greater than root 10. So based on the options, option D is the correct answer here. This is a question from graph theory. A given connected graph is a Euler graph if and only if all the vertices are of option A same degree, option B even degree, option C odd degree, and option D different degree. A given connected graph G is a Euler graph if and only if all the vertices of G are of even degree. So option B is the correct answer here. This is a question from graph theory. The maximum number of edges in an n-node undirected graph without self-loops is, and 4 options are given. Since the graph is undirected, it means the order of edges doesn't matter. And also we are having no self-loops. So what is to be done here is we have to insert an edge between all possible pair of vertices. Therefore, this problem reduces to finding the count of number of subsets of size 2 chosen from a set of vertices. As we have n vertices, this is exactly equal to the binomial coefficient of C of n comma 2, which is equal to nc2, which is equal to n factorial divided by 2 factorial into n minus 2 the whole factorial, which is again equal to n into n minus 1 by 2. So the correct answer is option B, n into n minus 1 by 2. This is a question from digital logic. The minimum number of NAND gates required to implement the Boolean function A plus AB bar plus AB bar C is equal to, and 4 options are given. Let's try to solve this. We have A plus AB bar plus AB bar C. So taking A as common, we have 1 plus B bar plus B bar C. This is equal to A into 1, which is equal to A. So here there is no requirement of NAND gates as we just need to implement A. So the correct answer here is no NAND gates. So answer is option A, 0. This is a question from digital logic design. The minimum Boolean expression for the following circuit is, and 4 options are given. We need to consider the different paths through which current can flow in the circuit by making the circuit complete. So current can flow through this path and reach here. So it can be A followed by B plus C, or current can directly flow here and reach the output. That will be A, B, or current can flow either through this and reach C and reach here. It will be A plus B followed by C. So the minimum Boolean expression would be A into B plus C followed by AB or A plus B into C. You can follow any three of the path. So this would be AB plus AC plus AB plus AC plus BC. AB and AB are repeated, so let's cut one. AC and AC are also repeated, so let's cut one. So the final answer would be AB plus AC plus BC. This would be the final answer. So we have AB plus AC plus BC, and option A is the matching answer. Option A is the correct answer here. This is a question from digital logic. For a binary half subtractor having two inputs A and B, the correct set of logical expressions for the output D equal to A minus B and X borrow are. So let's first write the truth table. We have inputs A and B, and D means difference, which is equal to A minus B, and X, that is equal to borrow. We have 0 0 0 1 1 0 and 1 1. So 0 minus 0, the difference is 0 and the borrow is also 0. 0 minus 1, the difference is 1 but the borrow will be 1. 1 minus 0, the difference is 1 but the borrow is 0. 1 minus 1, the difference is 0 and the borrow is also 0. Now for the logical expression for D, let's see where D is high. D is high in these two cases. That is, D is equal to A bar B plus A B bar, and borrow is high in the second case, that is this. So borrow is equal to A bar B. So let's see the options. Based on the options, here we have A bar B plus A B bar, and X is equal to borrow is equal to A bar B. Option C is the correct answer here. This is a question from digital logic design. Consider the following gate network. Which one of the following gate is redundant? Let's try to find out the output here first. This gate 1 will produce W bar. Gate 2 will be having W bar set. Gate 5 will be producing Z bar. And gate 3 would be producing Z bar XY. And 4 will be having the sum of all the outputs that are produced. So we'll be having W bar plus W bar Z plus Z bar XY as the output. We can take W bar as common. 1 plus Z plus Z bar XY, which is equal to W bar plus Z bar XY. So this is the final output. So W bar is relevant. So gate 1 is relevant. Z bar XY is there. Z bar is produced by gate 5 and XY is produced by this. So this is also relevant. So W bar set is not present in the output, and it is not affecting the output as well. So gate 2 is irrelevant here. So it is redundant. Option B, gate 2 is redundant here, and it is the correct answer. This is a question from digital logic. The dynamic hazard problem occurs in A, combinational circuit alone, B, sequential circuit, option C, both A and B, and option D, none of the above. So first of all, what is dynamic hazard? Dynamic hazard. The definition for dynamic hazard is that for a single input change, the output changes more than once in dynamic hazard. So for single input change, output changes more than once. The basic reason for this is that for larger circuits, there may be different routes to the output. If each route has different delay, then output change can occur more than once. Now, in combinational circuits, the delay in the logic gates such as NAND or NOT can cause this hazard. And in sequential circuit, delay by flip-flops can cause this hazard. So option C, both combinational circuit as well as sequential circuit has this problem of dynamic hazard. So option C, both A and B is the correct answer here. This is a question from digital logic design. The logic circuit given below converts the binary code y1, y2, y3 into which of the following options? Let's try to understand what the circuit produces. This y is the binary and x would be the output. We have y1, y2, y3. We have x1, x2, x3. This in binary form would be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now let's calculate what the output corresponding to this. For 0, 0, 0 we have 0, 0, 0 as the output. For 0, 0, 1 it will be 0, 0, 1. For 0, 1, 0 it will be 0, 1, 1. Then it will be 0, 1, 0. It will be 1, 1, 1. This will be 1, 1, 0. This will be 1, 0, 0. This will be 1, 0, 1. So based on the options we have XS3, gray code, BCD and Hamming code. So based on the options, it is neither BCD nor XS3 or Hamming code or gray code. So actually none of the options matches here. But in the question, the official answer key, it is given as gray code, but that is not correct. The correct answer here should be none of the above. This is a question from digital logic. It is asking what will be the output of the following circuit, and four options are given. So let's assume two possibilities. The input here can be either 0 or 1. Let's assume input is 0. Then here it will be 1. This one will be passed to this NOT gate. The output would be 0. This output will be passed to this NOT gate and the output will be 1. This again changes the input. So this will be oscillating between 0, 1, 0, 1, 0, 1 like this. Now assume the input as 1. If it is 1, it will be 0, then it will be 1, then it will be 0. This case, if the input is initially 1, it will be oscillating between 1, 0, 1, 0, 1, 0, etc. So the correct answer is it is an oscillating circuit and its output is a square wave as it oscillates between 0 and 1 like this. The output will be an oscillating circuit and output will be a square wave. So the correct answer is option A, an oscillating circuit and its output is a square wave. This is a question from digital logic design. If 12A7C in hexadecimal is equal to X in octal, then the value of X is what? Let's first write 12A7C in hexadecimal to binary. So C would be 1100, 7 would be 0111, A would be 1010, and 2 is 0010, and 1 is 0001. Let's rewrite it a bit for clarity. 0001, 0010, 1010, 0111, 1100. This is the binary equivalent for this hexadecimal number. Now to convert it into octal, let's group it from LSB in pairs of 3. Grouping it in pairs of 3, we get 1, 0, 0. This is one group. Next group is this 1, 1, 1. Next group is this 0, 0, 1. So from here itself, let's try to see if we are able to get any answers or not. This would be 4. This would be 7. So this can be answer. This can be an answer. This can be an answer. Now this is 1. So 174. All these have 174. Now let's take the next value. That is 101. 101 means 5. So we have 5174. 5174. So most probably this would be the answer or this can be the answer. Now let's see the next value. That is 010. This is 2. We have 25714, 25174 and 25174, either B or D. So next, see the next option, that is 010. We have 010 means again 2. So based on the options, these are leading zeros, they are not relevant here. So correct answer is 225174 and option D is the right answer here. This is a question from Digital Logic Design. The XS3 code is also called and 4 options are given. So first of all, what is XS3 code? The XS3 code for a given decimal number is determined by adding 3 to each decimal digit in the given number and then replacing each digit of the newly found decimal number by its 4-bit equivalent. For example, the XS3 for the number 24 can be found out by 2 and 4 and adding plus 3 to each of it. We will get 5, 7. Now we are trying to write it in 4-bit binary format. We have 0101, 0111. Therefore, the XS3 code for 24 is this. The key feature of XS3 is that it is self-complementing. In other words, what is self-complementing? It means that the ones complement of an XS3 number is the XS3 code for the nines complement of the corresponding decimal number. An important feature of an XS3 code is self-complementary. So the correct answer here is option C, self-complementing code. The XS3 code is also called as self-complementing code. This is a question from Digital Logic Design. The simplified SOP, that is sum of product, form for the Boolean expression P plus Q bar plus R bar into P plus Q plus R into P plus Q plus R bar is. So let's try to solve it. The expression is P plus Q bar plus R bar into P plus Q plus R into P plus Q plus R bar. Let's try to solve it. P into P we have P plus PQ plus PR plus PQ bar plus Q bar into Q is 0. Then we have RQ bar plus PR bar plus QR bar plus R bar into R is 0. This into this whole expression, that is P plus Q plus R bar. Now let's rewrite this. We can write it in such a way that taking P as a common factor from here, P into 1 plus Q plus R plus Q bar plus P R bar plus Q bar R plus Q R bar into P plus Q plus R bar. This whole equation turns out to be 1. So we have P plus Q bar R plus Q R bar into P plus Q plus R bar. Now again rewriting, we have P plus PQ plus PR bar plus PQ bar R plus Q bar R into Q is 0 and Q bar R into R bar is also 0 plus PQ R bar plus Q R bar plus Q R bar. This again turns out to be Q R bar. So again rewriting, taking P as the common factor, P into 1 plus Q plus R bar plus Q bar R plus Q R bar plus Q R bar. This whole term turns out to be 1, which is equal to P plus Q R bar. This is the answer. So based on the options, option B, P plus Q R bar is the correct answer here. This is a question from Digital Logic Design. Which of the following number is the same as its 2's complement? And 4 options are given. Let's try to find out the 2's complement of each number. 1010, the 2's complement. One easy method to find the 2's complement is that traverse the number from LSB to MSB and write the bit same as it is until you encounter a 1. So once you encounter 1, then after that the rest of the bits are to be complemented. So how we can find the 2's complement of 1010 is that traverse from LSB to MSB. So 0 we write it as it is, 1 we write it as it is. Now since 1 is encountered, from here on we find the 1's complement, that is 1 0. So the 2's complement of 1010 is 0110. So this is not the correct answer. Now second option is 0101. So we write 1 as it is, that is this one. Now we complement this, that is 101. This is also not correct. Now let's see option C, 1000. 000 as it is, 1 as it is. So this is the correct answer, that is 1000. The 2's complement also will be 1000. So for 1001 we have 1 as it is. Now we are complementing 110. This is also not equal. So the correct answer is option C, 1000. This is a question from digital logic design. The functional difference between SR flip-flop and JK flip-flop is that, and 4 options are given. Option A, JK flip-flop is faster than SR flip-flop. JK flip-flop has a feedback path. JK flip-flop accepts both inputs 1, and option D, none of the above. The major difference between a JK flip-flop and an SR flip-flop is that in JK flip-flop, both inputs can be high. That is, when both the inputs of J and K are 1, then the output Q is toggled. It means that the output alternates between 1 and 0. The only difference in SR flip-flop is that this condition, that is both input being 1, is not acceptable. So the functional difference between SR flip-flop and JK flip-flop is that JK flip-flop accept the input 1 in both cases for both J as well as K. So option C is the correct answer here. This is a question from computer organization. Consider a non-pipeline processor with a clock rate of 2.5 GHz and an average cycle per instruction of 4. The same processor is upgraded to a pipeline processor with 5 stages, but due to the internal pipeline delay, the clock speed is reduced to 2 GHz. Assume that there are no stalls in the pipeline. The speed up achieved in this pipeline processor is. So let's calculate the time taken for n instructions with a non-pipeline processor. Number of instruction is equal to n. Now we have one instruction. It takes 4 clock cycle, and the frequency is equal to 2.5 gigahertz, which is equal to the time taken per clock, that is equal to 1 by 2.5 gigahertz, which is equal to 0.4 nanoseconds, that is time per clock. So total time without pipeline, here we are assuming n instructions, so we have n into 4, this 4, that is for one instruction we are taking 4 clock cycle, and the time period for one clock cycle is 1 by 0.4. Sorry, it is 0.4. 4 into 0.4 nanoseconds. This is first point. Now for pipelining, how can we calculate? Under ideal situation, the pipelining, it will take one clock for one instruction. The frequency is given as frequency is equal to 2 gigahertz. So time period is equal to 0.5 nanosecond, and CPI is equal to 1, because in pipeline system under ideal condition the CPI is equal to 1. So we can calculate it as the total time taken, total time with pipeline for n instructions is equal to n into 1 into 0.5 nanoseconds. This is point number 2. So the speed up is equal to time without pipeline by time with pipeline. N into 4 into 0.4 nanoseconds divided by N into 1 into 0.5 nanoseconds. We have speed up is equal to 3.2. So the correct answer here is option A, 3.2. This is a question from C programming. Here we have an integer k equal to 5, a pointer variable which stores the address of k, a double pointer variable which stores the address of the pointer variable p, and we are asked to print the value of k star p double star m. So let's try to solve it. Here k, the value of k is 5 and it is stored at location 100. Now p is a pointer variable which is storing the address 100. So this is the address and it will point to here. The address of pointer variable p is 200. Now m is a double pointer variable storing the address of p, that is 200, and this is at address 300. Now let's see what we are trying to print. First we are trying to print the value of k. K is having the value 5. Now we are trying to print star p. P means the value inside this, that is 100. Star p means it will move here. So we are again printing the value of 5. Now star m means, first star m means 200 here, it will point to here. This is star m. Now here this is having the value 100. Star m would point to here, that is 5. So 555 would be the output. Based on the options, option A is the correct answer here. This is a question from operating system. Consider a disk pack with 16 surfaces, 128 tracks per surface and 256 sectors per track, and 512 bytes of data are stored in a bit serial manner in the sector. The capacity of the disk pack and the number of bits required to specify a particular sector in the disk is respectively, and 4 options are given. So to find the total capacity of the disk, we have to perform the following. We have 16 surfaces, that is 2 to the power 4, and in each surface we have 128 track, that is 2 to the power 7, and in each track we have 256 sector, that is 2 to the power of 8 sector, and within each sector we have 512 bytes, that is 2 to the power of 9. So in total we have how much? That is 2 to the power, that is 9 plus 8 plus 7 plus 4. We will be having 9 plus 7 plus 8 plus 4, that is 2 to the power of 28 bytes. So we can rewrite it as 2 to the power of 8 into 2 to the power of 20 bytes. This is 256 megabytes. So either option A or option B can be the correct answer here. Now we are asked to find out the number of bits required to specify a particular sector. To find a particular sector, we have to first find the surface, then we have to find which track we are looking into, and then we have to find that particular sector within the track. So we need how many bits? To identify a particular surface, we want 4 bits because 16 surfaces are there. Then to identify a particular track within a surface, we need 7 bits because of 128 tracks per surface. Then to identify one particular sector within a track, we need 8 bits because 256 sectors are there. So in total, we have 19 bits. So based on the option A, 256 megabyte is the total disk capacity, and to find a particular sector, we need 19 bits. This is a question from operating system. Let the page fault service time be 10 milliseconds in a computer with average memory access time being 20 nanoseconds. If one page fault is generated for every 10 to the power 6 memory access, what is the effective access time for the memory? Here one important point to note here is that page fault service time is in millisecond and the memory access time is asked in nanoseconds, and the final answer they are expecting it in nanoseconds. So that conversion from millisecond to nanosecond has to happen. So first is page fault time, that is page fault service time is equal to 10 milliseconds, which is equal to 10 to the power of 7 nanoseconds. Now main memory access time is equal to 20 nanoseconds. and one page fault is generated for every 10 to the power of 6. So page fault rate is equal to 1 by 10 to the power of 6, which is equal to 10 to the power of minus 6, and page hit is equal to 1 minus 10 to the power of minus 6, which is equal to 0.999999. Now the effective memory access time is equal to page fault rate, that is 10 to the power of minus 6 into page fault service time, that is 10 nanoseconds or 10 to the power of 7 nanoseconds plus page hit rate, that is 0.999999 into 20 nanoseconds. We have 29.9 nanoseconds as the answer. So based on the options, option B 29.9 is the correct answer here. This is a question from computer organization. Register renaming is done in pipeline process and four options are given. Register renaming is done to eliminate write after read and write after write dependency between instructions which cause pipeline stalls. So let's see an example. We have instruction I1, that is to read A to B, and I2 as write D to A. This has a write after read dependency, between this A and this A. So this instruction is rewritten as write D to A bar. Here the var dependency is actually an anti-dependency and there is no real dependency except the fact that both uses the same memory location. So register renaming can avoid this. Similarly, in write after write also, register renaming can avoid such issues. So the correct answer here is option C. Register renaming is done in pipeline process to handle certain kinds of hazards. This is a question from computer organization. In which class of Flyn's taxonomy von Neumann architecture belongs to? In computing, single instruction, single data is a computer architecture in which single Unicode processor executes a single instruction stream to operate on data stored in a single memory. So this corresponds to the von Neumann architecture. So in Flyn's taxonomy, this is option A, SIST, that is single instruction stream, single data stream. So option A is the correct answer here. This is a question from C programming. What will be the output of the following program? We assume that this program is running in a little Indian machine. And we are given short A is equal to 320, a character pointer, and we are trying to make this character pointer point towards this short variable named A. We are trying to print out the value. So first of all, what is little Indian processor or little Indian byte order? In little Indian byte order, the least significant byte of the data is placed at the byte with lowest address. The rest of the data will follow as it is. So here the value of A is 320. In 2-byte representation, it would be as follows. 0, first byte would be 0, 0, 0, 0, 0, 0, 1. How many bits are there? 1, 2, 3, 4, 1, 2, more 0. This would be the first byte, and the second byte would be 0, 1, 0, 0, 0, 0, 0, 0. This is the usual representation. Suppose this is at starting address 100, this would be at 101. This is LSB and this is MSB. But in little endian byte order, little endian, what happens is the LSB or this byte address would be placed first. So we'll be having a format like this: 0100 0000 followed by 000000001. Now what happens here is that this is a character pointer. So PTR, since it's a character pointer, on dereferencing it will output to a single byte and it will be pointing to this particular byte. So the value at this address is 64. So it will print the value 64. So based on the options, option C is the correct answer here. This is a question from C programming. We are given a C code and two integer variables j and n are declared. J is equal to 1 while j less than or equal to n, j is equal to j into 2. The number of comparisons made in the execution of the loop for any value n greater than 0 is. So let's make the number of comparisons count. So suppose let's draw a table first. We have n and number of comparisons. Number of comparisons. Assume n is equal to 1. If n is equal to 1, then j is equal to 1, n is equal to 1. So the number of comparisons here would be, for j equal to 1, one comparison would happen. Then j will be multiplied by 2. So for j equal to 2, two comparisons would happen and we exit the loop. So we have two comparisons. Now assume n is equal to 3. Here we have three comparisons. Initially j will be equal to 1. Here we are comparing it with 2. So j less than or equal to 2. So in first comparison j is equal to 1. In the second comparison j is equal to 2. In the third comparison j is equal to 4. So we have three comparisons 1, 2 and 4. Similarly for value 3 we have three comparisons, that is j equal to 1, 2 and 4. Now let's see the value when n is equal to 4. When n is equal to 4, we have 4 comparisons, that is j will be equal to 1, 2, 4 and 8. Here when j is equal to 1 and n is equal to 4, one comparison, then we multiply it by 2, so we get 2. Here n will be 4, then 2 into 2 4, n will be 4, 4 into 2 8, here it will be 4. This will be the exit condition. Similarly here this will be the exit condition. So if we follow like this, it follows a pattern where the correct answer would be log of n to the floor plus 2. This would be the correct answer. But based on the options, the most appropriate one we have here is log of n to the floor plus 1. This is because we can make assumption in two ways. Here, based on the question, the assumption that can be made is that we are not actually including the exit condition. We are just computing the condition where we are entering the loop. So if we are having log of n to the floor plus 1, the number of comparisons would be 1, 2, 2, 3. So the pattern here is we are not comparing the exit condition. We are just comparing when we are entering inside the loop. So the most appropriate answer here would be option D, log n to the base 2 plus 1. This is a question from data structures. The following postfix expression with single digit operand is evaluated using a stack. This is the expression. Note that raise to is the exponential operator. The top two elements of the stack after the first multiplication is evaluated are. So here we are given an expression. The expression is in postfix. So to evaluate the expression, these are the following rules. If operand push to stack, if operator pop top two elements and the top element equal to A, second element equal to B. Then we evaluate the result. Evaluate result B operator A and push to stack. This is the basic idea to solve the question. Now let's try to solve it. Initially, the stack will be as follows. We push 8, then we push 2, then we push 3. Now we have encountered raise 2. So we pop these two elements. This is A and this is B. A is 3, B is 2. And the operation is B operator A. So we have 2 to the power 3, which is equal to 8. And we push 8 back. Now the stack becomes like this. We have 8 and 8. Now we have reached slash. So we pop these two operators. 8 by 8 is 1. So we push 1 onto the stack. Now we have 2 and we have 3. As of now we have reached here, this point. Now the question is the top two elements of the stack after the first star is evaluated. Now we have received the star operator. So we pop these two and the multiplication results in 6. So we have 1 and 6. So the question asks for top two elements of the stack after first star is evaluated, and the correct answer is 1, 6. So option A 6, 1. The order is not mattering here. So option A 6, 1 is the correct answer here. This is a question from algorithms. The average number of key comparisons required for a successful search for a sequential search on item is, and 4 options are given. So first of all, let's find out the total number of comparisons on searching n items. It is equal to number of comparison on first element. That is number of comparison if first element plus number of comparison if it is second element plus etc. Number of comparison if nth element. This is equal to 1 plus 2 plus 3 etc. up to n. This is equal to n into n plus 1 by 2. So the average comparison will be total comparison divided by total element, which is equal to n into n plus 1 by 2 the whole divided by n. Cutting this n and n, we get n plus 1 by 2. So based on the options, option C, n plus 1 by 2 is the correct answer here. This is a question from data structures. A hash function f is defined as f of key is equal to key mode 7 with linear probing while inserting keys 37, 38, 72, 48, 98, 11, 56 into a table indexed from 0 in which location the key 11 will be stored. So the initial 0 will be, or the 0th location would be indexed as 0. So the hash function is f of k is equal to k mod 7 and linear probing is used. So let's first draw the table. We have index starting from 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5 and 6. So the first element is 37. 37 mod 7 is equal to 2. So in location 2, 37 would be inserted. Second one is 38. 37 is inserted at location 2 actually, not 3. So 37 would be inserted at location 2. Now 38. 38 mod 7 will be inserted at location 3. We have 38. Now 72. 72 mod 7 is also 2. But since 2 is already occupied, we'll look into 3. Since 3 is already occupied, we'll move into 4. So 72 is placed here. Now 48 is placed at which location? 48 mod 7 is equal to 6. So 48 will be placed at location 6. Now 98. 98 mod 7 is equal to 0. So in location 0, 98 will be kept. Now we have 11. 11 mod 7 is equal to 4, but 4 is already occupied, so we'll keep it at 5. So we have 11 here. So the question is asking us to find out in which location the key 11 would be stored. 11 would be stored at location 5. So based on the options, option C is the correct answer here. This is a question from data structures. A complete binary tree with n non-leaf node contains, and 4 options are given. So first of all, in a tree, the total number of edges is equal to E, which is equal to x minus 1, where x represents number of nodes. Since we have n non-leaf nodes, then we have x minus n leaf nodes as well as n minus 1 internal nodes, excluding root. So equating to the sum of degrees, here leaf has degree 1, internal node except root has a degree 3, root has a degree 2. Now using handshaking lemma, we can write it as x minus 1, x minus n into 1, which is degree 1, plus n minus 1 into 3 plus 1 into 2. Here x minus n means the number of leaf nodes. The leaf nodes has a degree 1, and n minus 1 means the internal nodes excluding root, which has a degree 3, and 1 is the root node, which is having a degree 2, which is equal to 2 times the number of edges. We can write it as x minus n plus 3n minus 3 plus 2 equal to 2e. Rewriting x plus 2n minus 1 is equal to 2x minus 2. Here e is replaced as e represents a number of edges which can be replaced by x minus 1. E is equal to x minus 1. So finally x is equal to 2n plus 1. So the correct answer here is option D, 2n plus 1. This is a question from algorithms. The algorithm design technique used in quicksort algorithm is, and 4 options are given. Actually, quicksort algorithm uses divide and conquer technique, in which we first choose a pivot element, and based on this pivot element, we are dividing the array into 2 halves. The elements to the left of the pivot element will be less than the pivot element, and elements to the right of the pivot element will be greater than the pivot element. Iteratively, we are again dividing it based on the pivot element, and this continues. So the correct answer here is option C, divide and conquer. And the best case and the average case time complexity of quicksort algorithm is order of n log n, whereas the worst case is order of n square. This is worst case. This is best case. And the case whether it is best, worst or average is determined by the position of pivot element. Pivot element position plays an important role. So correct answer here is divide and conquer. This is a question from theory of computation. A finite state machine can be considered to be a Turing machine of finite tape length, and 4 options are given: without rewinding capability and unidirectional tape movement, rewinding capability and unidirectional tape movement, without rewinding capability and bidirectional tape movement, rewinding capability and bidirectional tape movement. These are the 4 options. So a finite state machine can be considered to be a Turing machine of finite tape length without rewinding capability and unidirectional tape movement. The correct answer here is option A. So rewind is a procedure in which the first element of the input go to the last element on the tape and then processes it and then come back to the starting of the input tape. This is done only by the Turing machine because in Turing machine we have both bidirectional movement. So in finite state machine, what happens is we move from left to right one by one, but we cannot rewind. So there is no rewinding capability, as well as since we are moving only from left to right, we have unidirectional tape movement. Option A is the correct answer here. This is a question from theory of computation. Let L equal to W, which is equal to 0 plus 1 whole star, and W has even number of ones. This means that L is the set of all bit strings with even number of ones. Which one of the following regular expression below represents L? Let's see each option one by one. For option A, it cannot accept the string of the form 0, 1, 1, 0. Let's see. 0 star can accept 0, 1 can be accepted y, 1, 0 star it's not there, again 1, but then 0 it cannot accept. So such strings it cannot accept. Now let's see option C. In option C, it can accept a string with odd number of ones. Assume 0, 1, 0, 1, 1. Here 0, 1, 0, 1, 1. So this is a string of odd length number of ones. So this is also wrong. Option A is wrong. Option C is wrong. Now option D. It cannot accept any string with zero number of ones. For example, this is also a string with even number of one. This is also a string with even number of one. Here at least one is required. So this is also not the correct option. Let's see option B. Option B would be the correct answer here because it can accept all bit strings with even number of ones. So option B is the correct answer here. This is a question from algorithms. We are given a recurrence relation. T of n is equal to 2t of n to the power 1 by 2 plus 1 and t of 1 equal to 1. And we are asked to find out which of the following is true. So let's try to solve this recurrence relation. Given t of n is equal to 2t of root n, that is n to the power 1 by 2 plus 1. Solving it through iteration method, we can write it as t of n to the power 1 by 2 is equal to 2 into t to the power n raised to 1 by 4 plus 1. Now substituting t of n, we can rewrite it as 2 into 2t of n to the power 1 by 4 plus 1 plus 1, which is equal to 2 square t of n to the power 1 by 4 plus 2 plus 1. Now iteratively if we solve it, we can write it as t of n is equal to 2 to the power k into t of n to the power 1 by k plus 2 to the power k minus 1. Let n raised to 1 by 2 power k. This is actually n raised to 1 by 4. It will be n raised to 1 by 4. Here it will be n raised to 1 by 2 to the power k. Now we can write n raised to 1 by 2 to the power k is equal to 1. Under this condition only, we will get t of 1 equal to 1. So taking log on both sides, we can say that log n is equal to 2 to the power k. Now substituting, we get 2 to the power k into 1 plus log n minus 1. Now 2 to the power k is equal to log n, so we get log n plus log n minus 1. So ultimately option B, t of n is equal to order of log n is the correct answer here. This is a question from theory of computation. Consider the following statements about the context-free grammar, and we are given a grammar G. and 3 points are given. G is ambiguous. G produces all strings with equal number of A's and B's. G can be accepted by a deterministic pushdown automata. Which combination below expresses all the true statements about G? And 4 options are given. So let's consider each and every option one by one. First option is G is ambiguous. So a grammar G is said to be ambiguous if it can generate more than one parse tree for an input string. Consider this input string, that is AB, AB, AB. This can be generated using two parse trees. The first parse tree would be S derives SS. Now this S can derive again S and S. This S can derive AB. This S can derive AB, and this S can also derive AB. So this string is generated. Now one more parse tree is possible, that is S derives SS. Now this S can derive AB, this S can again derive SS, and this S can derive AB. Similarly, this S can derive AB. This manner, more than one parse tree is generated for the same input string. So G is ambiguous. This is correct. Second question or second point. G produces all strings with equal number of A's and B's. Here, the grammar is able to produce input strings of the form AB followed by BA or AB, AB. In that form, strings are getting generated. But one string that the grammar is not able to generate here is that it cannot generate AA, BB. This string cannot be generated by this given grammar. So this option 2, G produces all strings with equal number of A's and B's. This is not correct because AA, BB cannot be accepted or generated by this grammar. So this option is false. Option 3, G can be accepted by a deterministic pushdown automata. Yes, this is true. G can be accepted by a deterministic pushdown automata. How we can do is that, suppose upon seeing A, we push into the stack, and upon seeing B, we pop it. If we continue to do this, this can be done using a pushdown automata to derive the grammar G. So option 3 is correct. Now based on the options 1 and 3, option B is the right answer here. This is a question from theory of computation. If L and L complement are recursively enumerable, then the language L is. So one basic property is that if L is recursive, then L complement is also recursive. This is a basic property. Also, if L is recursively enumerable language, then L complement is not REL. This is another property. And the basic structure of the Chomsky hierarchy is that if this is recursive, then recursive enumerable is like this. This is recursive and this is recursively enumerable language. So from this basic properties, we can arrive that if L is recursive, then we can say that L is also recursively enumerable. As well as L complement is also recursive, then we can say that L complement is also REL. So the complement of REL is not closed, but the complement of recursive is again recursive. Now based on these two properties, we can say that if L and L complement are recursively enumerable, then the language L is recursive. Option D, recursive, is the correct answer here. This is a question from theory of computation. S derives ASA, BSB, A or B. The language generated by the above grammar over the alphabet A, B is the set of, and 4 options are given. First of all, let's try to find out the length of the string that is generated. This would generate even length string. This would also generate even length string. But to end the derivation, we will need A or B. So to even length string, we are adding one more character. So this would be an odd length string. So all palindromes are out of the question, as well as all even length palindromes are also out of the question. We can always generate odd length strings only, odd length. Now option B and C are possible, but here option C, strings that begin and end with the same symbol. But the above grammar cannot generate strings such as A, B, A, A. This is not possible by the above grammar. So we can say that the above grammar generates all odd length palindromes. Option B is the correct answer here. This is a question from Theory of Computation. What is the highest type number that can be assigned to the following grammar? S derives A derives BA, and B derives ABC. Let's try to understand what this grammar is deriving. S derives A derives BA, and B derives ABC. So the string generated is ABCAA. So the string generated is ABCAA. Since this is a finite string, this can be easily accepted by a deterministic finite automata. And the type 3 is the one which is belonging to deterministic finite automata. So this is the highest type number that can be assigned to the following grammar. So based on the options, option D would be the correct answer here. Even though this grammar can be even accepted by a Turing machine, the highest type number, since it is the most restrictive one, we can say that type 3 is the correct answer here. This is a question from data structures. Access time for the symbolic table will be logarithmic if it is implemented by linear list, search tree, hash table, self-organizing list. The correct answer here is option B, search tree. For a linear list, it will be almost order of n, and for hash table, it can be order of n if it is resolved using collision. So the correct answer here is option B, search tree. This is a question from compiler design. Recursive descent parsing is an example of top-down parser, bottom-up parser, predictive parser, or none of the above. The correct answer is option A, top-down parser. Recursive descent parser is a top-down parsing technique that constructs the parse tree from the top and the input is read from left to right. It uses procedures for every terminal and non-terminal entity. This parsing technique recursively parses the input to make a parse tree, which may or may not require backtracking. So the correct answer here is option A, top-down parsing. This is a question from compiler design. A top-down parser generates rightmost derivation in reverse, leftmost derivation, and leftmost derivation in reverse. Top-down parsers like LL1 and recursive descent parsers generate left to right scan, performing leftmost derivation of a string or a sentence. So the correct answer here is it generates a leftmost derivation. So option C is the correct answer here. This is a question from operating system. Relative mode of addressing is most relevant to writing coroutines, position independent code, shareable code, interrupt handlers. So in relative addressing mode, the effective address is obtained by adding the next instruction address with the address field. So the effective address, that is EA, effective address is equal to the value of program counter plus the operand part. Operand part. Where PC is the program counter register value. Therefore, relative mode of addressing is most suitable for writing position independent code. So the correct option is option B. This is a question from operating system. With single resource, deadlock occurs and four options are given. If there are more than two processes completing for that resource, if there is only two processes completing for that resource, if there is a single process competing for that resource, and option D, none of the above. So the basic condition for deadlock to occur is we have to satisfy four conditions. That is, first one, mutual exclusion. Second one is no preemption. Third one is hold and wait. Fourth one is circular wait. When there is only one resource, then the condition of hold and wait and circular wait gets eliminated. So these options get eliminated because of only a single resource. with the assumption that no process can use a resource for an infinite amount of time. Whenever a process will finish its execution and the process can get the resource. So there is no chance of deadlock occurring. So option D, none of these would be the correct answer here. This is a question from compiler design. Peephole optimization is a form of loop optimization, local optimization, constant folding, and data flow analysis. So in compiler design, peephole optimization is a kind of optimization performed over a very small set of instructions in a segment of code generated. This set is called peephole or a window. It works by recognizing sets of instruction that can be replaced by shorter or faster set of instruction. So peephole optimization is a form of local optimization, and the correct answer here is option B, local optimization. This is a question from operating system. At a particular time of computation, the value of counting semaphore is 7. Then 20 P operation and XV operations were completed on the semaphore. If the new value of the semaphore is 5, what will be the value of X? So let's understand what does P and V does. P essentially decrements the value of semaphore by 1. So P decrements semaphore by 1, whereas V operation V, it increments semaphore by 1. Now based on this concept, initially the value of semaphore is 7. In this semaphore we are performing 20 P operations, so the value is decremented by 20, and then XV operations are performed, which means the value is incremented by X times. Now the final value is 5. So what will be the value of X? X will be 7 minus 20 minus 5 is equal to minus X. So the correct answer here is minus 18 equal to minus X. X is equal to 18. So the correct option here is option A, 18. This is a question from operating system. A system has 3 processes sharing 4 resources. If each processes need a maximum of 2 units, then deadlock can occur, deadlock can never occur, deadlock has to occur, deadlock may occur, or none of this. So we are given 3 processes, P1, P2, P3. We have 4 resources. Let's denote it by dot. 1, 2, 3, 4. Now each process require a maximum of 2 units. So let's assign each process the maximum requirement minus 1 units. So here we are assigning 1 resource to this process, 1 resource to this, and 1 resource to this. Now we are left with 1 more resource. Now this resource can be freely assigned to any one of this process. Then what happens here is that we are satisfying the maximum requirement for any process at a given time. So that process will complete its execution. Then 2 resources will be free. Now we can freely allocate the 2 available resources to the other resources so that the process can complete its execution. So as a result, deadlock can never occur in this case. So option A, deadlock can never occur, is the correct answer here. This is a question from operating system. Determine the number of page faults when references to the page occur in the following order: 1, 2, 4, 5, 2, 1, 2, 4. Assume that the main memory can accommodate 3 pages and the main memory already has the pages 1 and 2, with page 1 having been brought earlier than page 2. Least recently used page replacement algorithm is used. Let's write the reference string once again. We have 1, 2, 4, 5, 2, 1, 2, 4, and the main memory has 3 pages. Now 1 is already in the main memory as well as 2 is also there in the main memory. Now when we refer 1 and 2, it is a page hit, but when we refer to 4, it is a page miss. This is denoted by a dot. Now 4 is brought into the main memory. Now when we refer 5, 5 is also a page miss. So among the frames 1, 2 and 4, 1 is the least recently used, so it will be replaced by 5. Now when we refer 2, it is already page hit, and when we refer 1, it is a page miss. Now when we trace back, 2, 5 are already not the least, and we have 4. So 4 will be replaced by 1. Then we have 2. Again, when we refer 4, it is a page miss. Now, when we trace back, we have 5, 2, and 1 in the page frame. And which frame will be replaced? 2 will not be replaced, 1 will not be replaced, but 5 is the least recently used. So 5 will be replaced by 4. So counting the number of page faults, we have 1, 2, 3, and 4. So the correct answer here is option C, 4. This is a question from operating system. Working set t comma k at an instant of time is, and 4 options are given. Working set t comma k is the set of unique pages referenced during the past delta references within t unit of time. So option D, that is the set of pages that has been referenced in the last time unit, is the correct answer here. So option D is the right answer. This is a question from operating system. A CPU generates 32-bit virtual address. The page size is 4 kilobyte. The processor has a translation lookahead buffer which can hold a total of 128 page table entries and is 4-way set associative. The minimum size of the TLB tag is. So the 32-bit virtual address can be divided into two parts. That is the offset and the page frame number. Page frame number. So the page size is 4 kilobytes, which is equal to 2 to the power 12 bytes. So from this 32-bit, we are assigning 12 bits to this. So now we are having 20 bits of address to refer the page frame number. The other information that is given here is that TLB is 4-way set associative and it can hold 128 page table entries. So the total number of sets in the cache is 2 to the power 7, which is 128 divided by 2 to the power 2, that is 4. So we have 2 to the power 5. This is the total number of sets in the cache. So 5 bits are needed to denote the particular set number, and remaining 20 minus 5, 15 bits is required to find the TLB tag bit. So this 20 bit, that is this 20 bit, is again split into 15 bits for tag and 5 bits for set offset. And the question asked here is, what is the minimum size of the TLB tag? It is 15 bits. So the correct option here is option C, 15 bits. This is a question from operating system. For the real-time operating system, which of the following is the most suitable scheduling scheme? Round robin, preemptive, first come first serve, random scheduling. The correct answer here is option B, preemptive. Because in preemptive scheduling, we can always preempt other processes based on priority. In real-time operating system, we have different tasks to perform simultaneously, and there are a few tasks which need to be performed first on priority basis. So considering the other options such as round robin, first come first serve, and random scheduling, preemptive scheduling is the best choice for a real-time operating system. And the correct answer is option B. This is a question from operating system. In which one of the following page replacement policies Beladi's anomaly may occur? FIFO, optimal, LRU, or MRU? Beladi's anomaly tells that it is possible to have more page faults when increasing the number of page frames. And this type of anomaly is usually seen in FIFO based algorithms. So the correct answer here is option A, FIFO. This is a question from database. Consider the join of a relation R with a relation S. If R has m number of tuples and S has n number of tuples, then the maximum and the minimum size of the joins respectively are, and 4 options are given. So to find out the maximum number of tuples, let's consider the situation. The common attribute among the relation R and S is a identical value. So Let's see an example. Relation R and relation S. This is the case for maximum. So A and B are the attributes here. Here we have A and D. So the values are 1, 2, 1, 3, 1, 4. Here we have 1, 10 and 1, 11. So when the common attribute contain identical values, here the common attribute is A, here the common attribute is A. All the values here are identical with the values here. Now the maximum number of tuples that are possible here is the cross product. So the relation would have total R natural join S would be A, B and D. So we'll match this row with these two rows, this row with these two rows and this row with these two rows. So we'll have 1, 2, 10, 1, 2, 11, 1, 3, 10, 1, 3, 11. Then we have 1, 4, 10 and 1, 4, 11. So we have in total m cross n, that is m into n number of tuples in the case of maximum. So now itself the options A and C are eliminated. Now let's consider the minimum number of tuples cases. In minimum number of tuple case, when the both relation have a common attribute but no tuple in both relation matches, the situation will be relation R and relation S. Here we have A, B, here we have A, D. Here we have 1, 2, 1, 3, 1, 4. We have 2, 10, 2, 15. When we perform R natural join with S, the common attribute is not having any relation, that is any values that is in common. So here we'll get no tuple. So minimum would be equal to 0 and maximum would be equal to m into n. So the correct option here is option B. Maximum is mn and minimum is 0. This is a question from database. Let R having attributes A, B and C and S having attributes D, E, F be two relations in which D is the foreign key of S. This is an important point. D is the foreign key of S that refers to the primary key of R. Consider the following four operations in R and S. Insert into R, insert into S, delete from R and delete from S. Which of the following can cause violation of the referential integrity constraint above? So consider the example. Let R be the table in this form, having A, B and C, and S be another table having attributes D, E and F, D, E, F. So the basic point given here is that D is the foreign key and assuming A be the primary key. A is primary key of R. Now A will have unique values here. Let it be S1, S2, S3. This can be any value. Since D is the foreign key referencing A, we can have S1, S2 as sample values here. This is the table structure assuming. Let's see the first one. Insert into R. When we try to insert a new value into R, it will not cause any violation because there is no modification that is need to be done here. So this is okay. There is no issues with it. Insert into S. When we insert into S, if you are inserting a new tuple of the form S4 something here and something, that is D, E and F, this can cause the violation in the referential integrity constraint because since this D is referring to the A, If a new value is inserted in the table S, then it is necessary that this value should be inserted or this value should be available in the table R. But if we insert into S, we cannot guarantee that. So this is a violation of the referential integrity constraint violation. Next, deleting from R. When we delete a value from R, this can also cause violation in the referential integrity constraint, because suppose if you're deleting S2, this S2, that is this D is referring to this S2. So this can cause referential integrity constraint violation. So this is also a violation. Now delete from S. Deleting from S will not cause any violation of the referential integrity constraint, because even if we delete this, there is no issue here. So this is also okay. So the question is, which of the following can cause violation of the referential integrity constraint? So 2 and 3 can cause, and option B, both 2 and 3 is the right answer here. This is a question from database. The relation book title comma price contains the title and prices of different books. Assuming that no two books have the same price, what does the following SQL query return? Select title from book as B, where select count star from book as T, where T dot price greater than B dot price less than 5. The outer query selects all titles from book the table. So this is the outer query. For every selected book, the subquery returns count of those books which are more expensive than the selected book. This is what it happens here. The where clause of the outer query will be true for 5 most expensive book. So for example, count star will be 0 for the most expensive book and count star will be 1 for the second most expensive book. Let's consider an example and understand how this works. We have two tables, assume. This is table B and this is table T. We have book and price. Book and price. Here also we have book and price. We have A, B, C, D, E, F. We have 100, 200, 300, 400, 500 and 600. Similarly, we have A, B, C, D, E and F. We have 100, 200, 300, 400, 500 and 600. So the first query will be from book as B, we are selecting the first one, and this will be compared with the subquery. The subquery would be this, and it will be compared. A will be compared with all these values. It will be compared with this, with this, with this, all these values. So we are comparing the price of T dot price versus B dot price. This is B and this is T. Now 100 is equal to 100, so this will be not true. This will be false. Second case is T dot price 200 is greater than 100, so this will be true. This will be also true. This will be true. This will be true. This will be true. It returns 1, 2, 3, 4, 5. 5 is less than 5. This is false. So this A will not be taken. Now let's take 200. Now on 200, what happens is 200 will be considered and 100 is less than 200. So this will not be, this will be taken actually, because T dot price is greater than B dot price. So this will be true. This now we are considering this 200 is greater than 200. This is false, but 300 is greater than this. This will be true. This will be true. This will be true, and this will be true. So it returns 1, 1, 2. This will be also false. It will be written 1, 2, 3, 4. So this count is 4. 4 is less than 5. So this is also true. So it returns B 200. This is 1. Similarly, in the next iteration, it will be selecting 300 and it will be comparing with all these values. Now 100 is greater than 300 false. 200 is greater than 300 false. 300 is greater than 300 false. 400, 500 and 600 is greater. So we'll get C 300. Similarly for D, E and F, for all these cases we will get the values, that is D, E and F 1, 2, 3, 4, 5. It will be 400, 500, 600. This will be the result that is finally returned. So let's see the options. Titles of 4 most expensive books, false. Title of the 5th most inexpensive book, false. Title of the 5th most expensive book, false. Titles of the 5 most expensive books, yes. The 5 most expensive books are this, and this is what it is being returned. So the correct answer here is option D, title of the 5 most expensive books. This is a question from database. Goals for the design of the logical schema includes avoiding data inconsistency, being able to construct query easily, being able to access data efficiently, all of the above. So what is logical schema? A logical schema is developed using diagrams that define the contents of a database in the form of tables, and it also describes how the tables are linked with each for data access and how actually the data is stored in the database. So the major goals that is being considered while having a logical schema is that it should be avoiding data inconsistency. Also, it should be able to construct the query easily as well as being able to access the data efficiently. So all the 3 points are a must. So based on the options here, option D, all of the above is the correct answer here. This is a question from database. Given the relations employee and department, which of the following queries cannot be expressed using the basic relational algebra operations given here? Department address of every employee. This can be easily expressed using the basic relational algebra operations. So this is not the answer here. Employees whose name is same as their department name. This can also be represented using the basic relational algebra operations. All employees of a given department. This can also be represented. The sum of all employee salaries. Relational algebra of aggregate function, that is sum, cannot be generated using basic operation. So this query, that is the sum of all employee salaries, cannot be expressed using basic relational algebra operation. So the correct answer here is option C, sum of all employees salary. This is a question from database. Trigger is statement that enables to start any DBMS, statement that is executed by the user when debugging an application program, the condition that the system tests for the validity of the database user, statement that is executed automatically by the system as a side effect of a modification of the database. So the correct answer here is option D. Trigger is a statement that is executed automatically by the system as a side effect of a modification of the database. A trigger can be set off when we are using commands such as insert, delete, or update. Insert, delete, or update all can cause a trigger. So the correct answer here is option D. This is a question from database. The order of a leaf node in B plus tree is the maximum number of value and data record pointer pairs it can hold. Given that the block size is 1 kilobytes, data record pointer is 7 bytes, and the value field is 9 bytes long, and block pointer is 6 bytes long, what is the order of the leaf node? So the given data here is disk block is 1024 bytes. Data record pointer, data record pointer denoted by R is 7 bytes. The value size is 9 bytes. Value size V equal to 9 bytes. And disk pointer, disk block pointer P equal to 6 bytes. Let order of leaf be M. A leaf node in a B plus tree contain at most M record pointers at most m values and one disk block pointer. So let's write it down also. At most m record pointer, at most m values and one disk block pointer. Based on this, we can say that Rm plus Vm plus P will be less than or equal to the disk block size, that is 1024. We can say that R into M plus Vm plus P less than or equal to 1024. Rewriting 16M is less than or equal to 1018. M will be less than or equal to 63. So the correct answer here is option A, 63. This is a question from database. A clustering index is defined on the fields which are of type and 4 options are given. A clustering index, as the name suggests, is created when the data can be grouped into form clusters. Let's consider the example. We have two columns. One is roll number and other is subject. Let roll number be 101, 101, 102, 102, 102 and 103. The subjects be maths, science, social, maths, science and English. So based on the roll numbers, we can create clusters. This is one cluster, this is another cluster, and this is the third cluster. So we can generate the index file as follows. That is, the index file will have 101, 102 and 103. 101 will point to here, 102 will point to here, and 103 will point to here. So to create such kind of indexes, fields could be non-key attributes. That is, based on this, we can say that it could be non-key attributes, as well as an order is required so that we can form the clusters easily. So based on the options, option A, non-key and ordering would be the correct answer here. This is a question from software engineering. The extent to which the software can continue to operate correctly despite the introduction of invalid input is called reliability, robustness, fault tolerance, portability. The correct answer here is option B, robustness. Robustness is the ability of a software to withstand erroneous and invalid input. It is an important quality of a software. Robustness can be introduced in a software by introducing methods that focus on handling unexpected termination and unexpected action. So option B, robustness is the correct answer here. This is a question from software engineering. Which of the following is a functional requirement? Maintainability, portability, robustness, none of the above. So what is functional requirement? Any requirement that mentions or specify what the system should do is a functional requirement. That is, any requirement that specify what system should do. Example, business rules, administrative function, etc. These are some examples of functional requirement. Now, what is non-functional requirement? Non-functional requirement. Any requirement which specify how the system should perform a certain function. That is a non-functional requirement. Some examples include maintainability, portability, robustness. Maintainability, robustness, portability are example of non-functional requirement. And the question is, which of the following is a functional requirement? So option D, none of the mentioned is the correct answer here because maintainability, portability, and robustness are non-functional requirements. This is a question from software engineering. Configuration management is not concerned with controlling changes to the source code, choice of hardware configuration for an application, controlling documentation changes, maintaining versions of software. So what is configuration management? It is concerned with the development of procedures and standards for cost-effective managing and controlling changes in an evolving software system. It includes software version maintenance. So this option will not be the answer. It includes controlling changes to the source code management. So option A also will not be the answer. So it also involves controlling the documentation changes. This is also not the answer. Configuration management is not concerned with the choice of hardware configuration for an application. So option B is the right answer here. This is a question from software engineering. A company needs to develop a strategy for software product development for which it has a choice for two programming languages, L1 and L2. Number of lines of code (LOC) developed by language 2 is estimated to be twice the LOC developed by language 1. This is an important point. Twice the LOC developed by L1. The product will have to be maintained for 5 years. Various parameters for the company are given below in the table. So the parameters include man years needed for development. It is LOC by 10,000. It is also LOC by 10,000. Development cost is given here, and maintenance years is given as 5 years, and the cost per year for maintenance is also given. Total cost would be the sum of cost of development as well as maintenance. What is the LOC for L1 for which the cost of the project using L1 is equal to the cost of the project using L2? So what is this LOC value using which the cost of L1 will be equal to cost of L2? So let L1 be having X lines of code and L2 will be having then 2x lines of code. Now the total cost will be the sum of all this, that is man years needed for development. We have X, this is for L1 we are calculating now, X by 10,000 plus into development cost per man year, it will be this value plus 5 into this value, that is it will be product of this plus product of this. This will be equal to 2x divided by 1 2 3 4 into 75000 plus 5 into 50,000. We will get 100x plus 5 1 2 3 4 5 is equal to 150x plus this is separate 25,000. Solving this, we will get x is equal to 25,000 upon 50, which is equal to 5,000. So the value of x, that is lines of code in L1, is equal to 5,000. So the correct answer here is option B, 5,000. This is a question from software engineering. A company needs to develop digital signal processing software for one of its newest invention. The software is expected to have 20,000 lines of code. The company needs to determine the effort in person months needed to develop this software using the basic COCOMO model. The multiplicative factor for this model is given as 2.2 for the software development on embedded system, while the exponential factor is given as 1.50. What is the estimated effort in person months? First of all, effort applied based on COCOMO model is equal to AB into thousands of lines of code to the power B power P. The multiplicative factor is given as 2.2 and the exponential factor is given as 1.5, and kilo lines of code or thousands of lines of code is given as 20,000 divided by 1000, we will get 20. Now substituting this in the formula, we will get 2.2 into 20 to the power 1.5, which is equal to 196.77. So the correct option here is option A, 196.77. This is a question from software engineering. In the spiral model of software development, the primary determinant in selecting activities in each iteration is iteration cost, adopted process such as rational unified process or extreme programming, risk. In spiral model of software development, the primary determinant in selecting activities in each iteration is risk handling. The spiral model is a risk-driven software development model. Based on the unique risk patterns of a given project, the spiral model guides a team to adopt elements of one or more process models such as increment, waterfall, or evolutionary prototyping. So the correct answer here is option D, risk. This is a question from computer networks. Bit stuffing refers to inserting a zero in the user stream to differentiate it with a flag, inserting a zero in the flag stream to avoid ambiguity, appending a nipple to the flag sequence, appending a nipple to the uStream data. So bit stuffing refers to the insertion of non-information bits into the data. So the basic definition is it is inserting a zero in user stream to differentiate it with a flag. This is a major application of bit stuffing. Some other application of bit stuffing includes to fill the buffers or frames, or for bringing bit streams that do not have necessarily the same or rationally related bit rates up to a common rate. So based on the options, option A, inserting a zero in user stream to differentiate it with a flag, is the right answer here. This is a question from computer networks. Dynamic routing protocol enabled routers to dynamically discover and maintain routes, distribute routing updates to other routers, reach agreement with other routers about the network topology, all of the above. So what is the basic concept of dynamic routing? It is a process where a router can forward data via a different route or a given destination based on the current conditions of the communication circuit within a system. There are different dynamic routing protocols. Some of the examples are RIP, that is Routing Information Protocol. Routing Information Protocol. Other one is OSPF, that is Open Shortest Path First. These are some examples of dynamic routing protocol. Now, dynamic routing protocol enable routers to discover and maintain routes, distribute routing update to other routers, to reach agreement with other routers about the network topology. So options A, B, and C are correct. So the correct answer here is option D, all of the above. This is a question from computer networks. In Ethernet CSMA CD, the special bit sequence transmitted by the media access management to handle collision is called preamble, postamble, jam, none of the above. When collision condition is detected in Ethernet CSMA bar CD, the station stops transmitting the ongoing frame, transmits a jam signal, and then waits for random time interval before trying to resend the frame. Therefore, in Ethernet CSMA bar CD, the special bit sequence is transmitted by media access management to handle collision is called jam signal. So the correct answer here is option C, jam. This is a question from computer networks. Which networking protocol allow hosts to dynamically get a unique IP address on each boot up? DHCP, BootP, RARP, and ARP. So let's see each options. ARP, it stands for Address Resolution Protocol. It converts IP address to MAC address. So it does not give the host dynamically a unique IP address on each boot up. So this is not the answer. Second one is RARP. that is reverse ARP. It converts MAC to IP address. So this is also not the correct answer. The third one is bootp. The main difference between RARP and bootp is that bootp is going to run on application layer, whereas RARP runs on network layer. In bootp, it requests for asking IP address comes from application layer instead of network layer. So bootp is also not the correct answer. DHCP stands for Dynamic Host Configuration Protocol. The main difference between DHCP and bootp is that the table which is not need to be static in DHCP. That is, we create a table in the process of assigning IP address. This table need not be static and it is dynamic. So DHCP is a very popular and it is even used by most of the ISP where even we do not need to have a private IP when we use DHCP. So the correct answer is DHCP. It dynamically allocate unique IP on boot up. So the correct answer is option A, DHCP. This is a question from computer networks. In a token ring network, the transmission speed is 10 to the power of 7 bits per second and the propagation speed is 200 meter per microsecond. The 1 bit delay in this network is equivalent to, and 4 options are given. So let's find out the answer. Based on the given data, let's calculate transmission speed. Transmission speed, that is TT, is given as 10 to the power of 7 bits second per inverse. Now propagation speed is equal to TP equal to 200 meter per microsecond. So transmission time is equal to length by bandwidth, and propagation time TP is equal to distance by velocity. Now since TP is equal to 200 meter per microsecond, in 1 second distance covered is equal to 200 into 10 to the power of 6 meters, and 1 bit delay is equal to 1 upon bandwidth into velocity, which is equal to 1 by 10 to the power 7 into 200 into 10 to the power of 6, which is equal to 20 meter. So the correct answer here is option C, 20 meters of cable. This is a question from computer networks. The address of a class B host is split into subnets with 6-bit subnet number. What is the maximum number of subnets and the maximum number of hosts in each subnet? So in class B, we have 16-bit for subnet and 16-bit for host. Now 6-bit is used for subnetting. So maximum number of subnets possible is 2 to the power 6 minus 2, which is equal to 62. 62 subnet. Now number of bits in the host ID is equal to 32 minus 22. We get this 22 from 16 plus 6 bits for subnetting, which is 10 bits. This 10 bits is used for host. So the total number of hosts that is available is equal to 2 power 10 minus 2, which is equal to 1022. So we have 62 subnet and 1022 host. So the correct answer here is option C, 62 subnets and 1022 host. This is a question from computer networks. The message 11001001 is to be transmitted using CRC polynomial x to the power 3 plus 1 to protect it from errors. The message that is to be transmitted is and 4 options are given. Since the degree of the CRC polynomial is 3, we append 3 zeros to the message, and x to the power 3 plus 1 is written as 1 0 0 1. Let's try to solve it. 1 1 0 0 1 0 0 1 0 0 0 would be the message. This and the dividend and the divisor would be 1 0 0 1. Let's solve 1 0 0 1. It will be, ignoring this, we'll get 1 0 1 1. It will be again going as 1 0 0 1. Ignoring this, we'll get 0 1 0 0. Now it will be 0 0 0 0 0. Removing this, we'll get 1 0 0 and this 0. Then we'll again get 1 0 0 1. Ignoring this, we'll have 0 0 1, and then we'll get this one down here. Again it will be 0 0 0 0. Ignoring this, we'll get 0 1 1, and then putting this 0 here, we'll have this. Again it will be 0 0 0 0. Ignoring this, we'll have 1 1 0. Putting this 0 here, we'll get 1 0 0 1. Ignoring this one, we'll get 1 0 1 0. Again we'll have 1 0 0 1. Ignoring this, we'll get 0 1 1. This would be the value that will be appended to the message. So the message transmitted would be 1 1 0 0 1 0 0 1 0 1 1, and the option that matches with this, option B, it is 1 1 0 0 1 1 1 0 0 1, then 0 0 1 0 0 1 0 1 1 0 1 1. So the correct answer here is option B. This is a question from computer networks. What is the maximum size of the data that the application layer can pass on to the TCP layer below? So let's understand the size limits in each layers based on ISO OSI architecture. So in the data link layer and the physical link layer, we have data bar physical layer. There's limit of 1500 bytes. In the network layer, the size limit is 1480 bytes. In the transport layer, it is 1460 bytes. And mainly in the application layer, it can be of any size. Actually, it is the transport layer's responsibility to divide data into fragments and packets. Application layer is free from it, and it need not have any size restriction. So based on the options, option A, any size would be the correct answer here. This is a question from computer networks. Frames of 1000 bits are sent over 10 to the power of 6 bits per second duplex link between two hosts. The propagation time is 25 milliseconds. Frames are to be transmitted into this link maximally back when they are transmitted, that is within the link. What is the minimum number of bits that will be required to represent the sequence number distinctly? Assume that no time gap needs to be given between transmission of two frames. So the data that is given here is propagation time. Propagation time, that is TP, is equal to 25 milliseconds. Bandwidth equal to 10 to the power of 6 bits per second. So to fully utilize the channel, we must send 10 to the power of 6 bits into the channel in a second, which will be 1000 frames, as one frame is equal to 1000 bits. Now the propagation time is given as 25 milliseconds. To fully pack the link, we need to send at least 1000 into 25 into 10 to the power of minus 3 frames, which will be equal to 25 frames. So to represent the frames, we would require log to the base 2 25, which is equal to 5 bits. So the correct answer here is option D, 5. This is a question from Web Technologies. Which of the following is true only for XML but not HTML? It is derived from SGML. It describes content in layout. It allows you user-defined tags. It is restricted only to be used with web browsers. So SGML, it stands for Standard Generalized Markup Language. And it is extended to HTML and XML. So this option is not correct. Both XML and HTML are used to describe content and layout. So this is also not correct. And both XML and HTML is restricted only to be used within web browsers. But user-defined tags are only allowed in XML and not in HTML. So user-defined tags in XML it is allowed, whereas in HTML it is not allowed. So the correct answer here is option C. It allows user-defined tags. This is a question from computer organization. Consider a system with two level caches. Access times of level 1 cache, level 2 cache, and main memory are 1 nanosecond, 10 nanosecond, and 500 nanosecond respectively. The heat rates of level 1 and level 2 cache are 0.8 and 0.9 respectively. What is the average access time of the system, ignoring the search time within the cache? So this would be our first cache. This is L1, this would be L2, and this would be our main memory. This is main memory. So initially it will look in this cache. If it is not available, then it will be looking into this cache, and if it is not even available here, it will be looking into main memory. So let's write down the basic data that is given. Let H1 be hit ratio of level 1 cache, that is 0.8. H2 be hit ratio of level 2 cache, that is 0.9. Let T1 be time to access cache 1, that is 1 nanosecond, level 1 cache, and T2b time to access level 2 cache, that is 10 nanoseconds, and T3b accessing the main memory, and H3 would obviously be 1. So the basic formula to find out the average access time ignoring the search time within the cache is H1 T1 plus 1 minus H1 into H2 T2 plus 1 minus H1 into 1 minus H2 into HM, that is H3 would be 1 into T3. So basically this is equal to 0.8 into 1 plus 1 minus H1, that is 0.2 into 0.9 into 10 nanosecond plus 0.2 into 0.1 into 1 into 500 nanosecond. So in total it will be 0.8 plus 1.8 plus 10. So which will be equal to 12.6 nanosecond. So the correct answer here is option C, 12.6 nanoseconds. This is a question from C++ programming. If a class C is derived from class B, which is derived from class A, all through public inheritance, then class C member functions can access, and 4 options are given. So first of all, let's summarize the different access types according to who can access them in this particular table. So let's write access public, protected, and private. And the classes would be same class, derived class, and outside class. This would be the basic table. So now the table construction is done. For the same class, the public, private, and protected members can be accessed. Whereas for derived class, only the public and protected data members can be accessed. Whereas for outside class, only the public members can be accessed. Based on this table, we can say that if C is derived from class B, which is derived from class A, all through public inheritance, then class C members can access all the public and protected data of A and B and all of data of C. So option 4 would be the correct answer here. This is a question from programming languages. Which one of the following is correct about the statements given below? All functions called are resolved at compile time in C language. All function calls are resolved at compile time in C++ language. Actually, what is the concept of binding? Binding refers to the process of converting identifiers into address. Binding is done for each variable and function. C supports early binding in which all functions related to their function calls are resolved at compile time. C++ supports both early binding and late binding. But there are cases where C also supports runtime binding, as well as there are cases in C++ where the functions are resolved at compile time. So option D, both 1 and 2 are incorrect here because there are instances where both C language and C++ language are having resolution of the function calls done at runtime. This is a question from computer networks. When a DNS server accepts and uses information which is incorrect from a host that has no authority giving that information, then it is called DNS lookup, DNS hijacking, DNS spoofing, none of the mentioned. When DNS server accepts and uses incorrect information from a host that has no authority giving that information, it is called DNS spoofing. It is the act of disguising a communication from an unknown source as being from a known trusted source. Spoofing can apply to emails, phone calls, etc. So the correct answer here is option C, DNS spoofing. Now, what is DNS lookup? In computer networks, DNS lookup is the querying technique of DNS to determine an IP address associated with a domain. And what is DNS hijacking? It is also called as DNS redirection. It is a type of DNS attack in which DNS queries are incorrectly resolved in order to unexpectedly redirect users to malicious site. So option C, DNS spoofing is the correct answer here. This is a question from compiler design. A simple two-pass assembler does which of the following in the first pass? In a two-pass assembler, in the first pass, the tasks that are performed includes check to see if instruction is legal in the current assembly mode. Then address resolution is done. Then table creation, that is simple table creation, adding literals to the literal table. Then it allocates space for literals. These are some of the tasks that are performed by a simple two-pass assembler in the first pass. So option A, B, and C are all correct. So option D, all of these would be the right answer here. This is a question from engineering mathematics. What is the sum of infinity to the series 3 plus 6x square plus 9x to the power 4 plus 12x to the power 6, etc. given that modulus x is less than 1 and 4 options are given. Sum of the series is written as 3 plus 6x square plus 9x to the power 4 plus 12x to the power 6 plus etc. Applying minus x square on both sides, we will have minus 3x square minus 6x power 4 minus 9x power 6 minus 12x power 4, etc. Now we can write it as 1 minus x square into s of n is equal to, take 3 into 3 plus 3x square plus 3x power 4 plus 3x power 6, etc., which can be again rewritten as 3 into 1 plus x square plus x power 4 plus x power 6 plus etc. 1 minus x square s of n is equal to 3 into 1 by 1 minus x square, because this is a series in GP having infinite number and a equal to 1 and r equal to x, that is it is less than 1. So s of n will be equal to 3 by 1 minus x square the whole square. And based on the options, option B, C, 3 by 1 minus x square the whole square is the right answer here. This is a question from calculus. Limit x tends to 0, root of 1 plus x minus root of 1 minus x by x is given by, and 4 options are given. Limit x tends to 0, root of 1 plus x minus root of 1 minus x by x. Putting x equal to 0, we will get it in 0 by 0 form. Then applying L'Hospital's rule, that is differentiate upper limit and lower limit differently, we will get limit x tends to 0, 1 by 2 into root of 1 plus x plus 1 by 2 into root of 1 minus x. Now applying x as 0, we will get 1 by 2 plus 1 by 2, which is equal to 1. So the correct answer here is option C, 1. This is a question from discrete mathematics. If G comma dot is a group such that AB the whole inverse equal to A inverse B inverse for all A comma B belongs to G, then G is an commutative semigroup, abelian group, non-abelian group, none of this. A group is said to be abelian if A star B equal to B star A for all A comma B belongs to the group G. Since G comma dot is a group, we can say that AB the whole inverse is equal to B inverse A inverse. This is point number 1. It is given that AB the whole inverse is equal to A inverse B inverse. This is to point number 2. From 1 and 2 we can say that A star B is equal to B star A. So it is abelian. So the correct option here is option B, abelian group.